Hello and welcome back. In this particular video, we would be looking at some of the parallel architectures. So one would be the shared memory type of architecture, and then hopefully the other would be the distributed type. So we'll first look at where we have a system that is built with multiple cores processor. So a processor with multiple cores. They would also look at another one where there are multiple cores, but then there are more systems combined. I've been fortunate enough to get access to a cluster by my school, Knust. So I would be using that one for the demonstration of the mixed or the hybrid kind of memory architecture. So without wasting much time, let's get started. So the first one would be the demonstration of my machine. I'm currently using a Chromebook to perform the recording, and we'll first look at the architecture of the Chromebook, right? So in order to do that, I use the command lscpu, that's list the CPU properties, and then here we can see that here, so we have the number of CPUs here, right? The number of cores it has is 2 cores, right? And then here you consider is 0 and 1, core 0 and core 1, right? And then the number of threads it has, right? So it means that it has one CPU, that's one hardware with 2 cores, and then the core 0, core 1, and then the threads, right? The threads per core is just a core each, right? And then the cores per socket, so that's telling you that there are 2 cores on just one CPU, and there's just one socket on the machine, on the hardware. And then here we could see that the model name is AMD, so this architecture is from AMD, not Intel. And then let's look here. We have 5 compute nodes, 2 nodes, 5 compute cores. 2 cores are coming from the CPU, while 3 cores are coming from the GPU, right? And then what else? The virtualization we spoke about. This uses an AMD V virtualization from which can let the Linux that is running on it identify the CPU and use the whole CPU as though it is the Chromebook that is using the CPU. So the virtualization enables you to create a virtual machine, right, on the CPU. And basically that's it. This is the cache of the processor. And then yeah, for now that will be all. But then we can't look at the CPU without looking at the memory, because we said that every CPU needs a memory. So if I do free-h, right, so you see that here it's the CPU that is shown has 2.8 gigabytes of memory to work with. So which means that the 2 cores or the 5 compute cores in general would have to share these 2.8 gig of memory amongst themselves. So should I decide to run any parallel program or parallel application, they will be sharing this 2.8 gigabytes of memory. So basically that's for this system. Now let's go to the Knust cluster. Actually, I don't know how many they have, but I've been fortunate enough to have access to this one. So let me first, we said that you first have to access via the network. So use a secure shell and then your username. Sorry. And then I have, okay, so I'm in. So here, if I run the same command lscpu, we see that here we realize that the number of cores, right, available is 104. So there are 104 cores that are available on this cluster, and then that's from 0 to 103, right? And then the number of threads per core, so one core, each core has been multi-threaded, and the number of threads is 2 threads per core, right? And then the core per socket, there are 26, which means that for each hardware, CPU hardware, there's 26 cores on the CPU hardware. So if there are 26 cores, then eventually there will be like 4 of the CPUs, right? So let's see, and we are being told that there are 2 sockets, right? 2 sockets and then 2 nodes. So 2 sockets, 2 nodes. So it means that each node has 2 sockets on it, which means that in one node there is 26, 2 of 26 core CPU, and then in total they have 4, right? And then the model, this is by Intel, so the clock speed is 2.1 gigahertz. We spoke about clock speed in the previous video. And then here we have the cache memory, obviously. Important thing is to note here that we could see that the node 0 has 26 cores from 0 to 25, and then from 52 to 77, right? This is the number of cores in node 0, right? And then node 1 has from 26 to 51, and then 78 too. So this is telling us that this is not just one system unit that has a single CPU in it, but then multiple systems have been combined, right? Have been combined to get this for us. So basically this is just one of the clusters, and this might be a smaller one compared to the one by Google, Amazon, or Microsoft. And then let's look at the memory, right? Because every CPU needs a memory. So if I do the free, that's H here, you see that here the memory was what is 93 gig, which means that this could be more, but then which means that all the 104 cores, right, would have to, so this is the global memory, right? This is a global memory. I don't know how to show the local memories each, but then this is a global memory here, 93, which means that, so in a way it could be distributed. It could, obviously it's global, so it could be distributed, but then each having a local memory could also share the memory. So basically that's that. And yeah, so that'll be all for this video. Hopefully you've seen that these things are not just something we are reading about in books, but then they actually exist. So if you want to see or know how to write codes that could leverage the compute cores on your system or on your laptop, then you can go to the video where we talk about parallel programming with C or parallel programming with Python, and then get your hands dirty. If you enjoyed this video, please don't forget to like and subscribe and share with your friends, and I'll see you in the next video.